Hello, everybody. Welcome to our Cybersecurity for Beginners event. We're glad you decided to spend your morning, afternoon, or evening with us to learn a little bit more about this in-demand field of cybersecurity. I'm Jordan. I work on the marketing team here at Flatiron School. I'll be behind the scenes managing chat and Q&A, anything else that you need, while Eric, who is one of our awesome cybersecurity instructors, is going to be our fearless leader. Before I hand it off to him, here is our agenda for the evening. So we're going to start with a quick intro to Flatiron School for any of our new friends on the line today. And we're going to end with audience Q&A and next steps. So throughout the event tonight, feel free to drop questions into the chat box or the Q&A section. We'll get to as many as we can. If the topic is relevant to what Eric's talking about, we may surface those questions throughout the presentation, but otherwise we're going to save them towards the end for a dedicated Q&A. We're happy to answer any questions you have about the specific topic that we're talking about tonight, or what it's like to stay at Flatiron School, which, speaking of, for those who are unfamiliar, so Flatiron School is an award-winning coding bootcamp that has helped thousands of students break into tech and land jobs that they love. We were founded in 2012 in New York City, and we believe that education is the best investment you can make for your future. So we're committed to helping you learn the skills that you need to change yours for the better. Hence our mission statement, which is shown here. Flatiron School currently offers career-changing courses in software engineering, data science, cybersecurity, and product design with flexible pacing options. We have campuses across the country in the cities that are listed here on the right. If you're in Colorado, you may be more familiar with our sister school, SecureSet, which has campuses in Colorado Springs and Denver. We believe that our true differentiator is our proven job search framework, which has helped thousands of grads break into the tech industry and land jobs at companies like these, along with many, many more businesses of all shapes and sizes. The best boot camps get graduates jobs, and we're happy to prove that. Our 2020 jobs report is a third-party verified document, and it's available on our website in full, but here is a sneak peek. All right, that is the quick overview of Flatiron School. Now, I want to get you to get what you came for from Eric today. But just a reminder that you are going to receive a recording and any recap materials from me first thing tomorrow morning. I see that some of you did not receive the malware analysis recap from last week. So if you didn't, feel free to drop that in the chat here. I'll make sure to resend it. Sometimes the stuff through Eventbrite and Meetup gets caught up in spam filters, so I'll make sure to send that again. With that, I am going to pass it over to Eric to get started.
All right, can everyone hear me? Are we good here?
Yes.
Awesome. Hopefully everyone's doing good tonight. I want to shout out to Colorado Springs because that's my alma mater. I actually taught at SecureSet there for a good while, and then was bumped to a different department or a different campus. I'm at the online campus now. For some of you that may have attended some of these about a month and a half ago, or 2 months maybe, I did a talk on Python automation. I'm saying this now because I, once again, if you were in that one, I also forgot an intro slide then. I forgot another intro slide for myself here. So I'm quickly talking. Ooh, I see a Proton mail and mail address. Good for you. But I am Eric Keith. I have taught at Flatiron SecureSet for about 3-4 years now. 2018, so about a little over 3 years now. Really enjoy it. I came out of IT. If you remember, I came out of a system admin job, then I went through a boot camp, then went out, did a lot of internships and some jobs, and then got me back here into doing some other stuff, and eventually made my way into the teaching side of stuff, which I really do love. I really love it. And today we're actually going to teach something that I used to teach a few years ago, Intro to Virtualization. A lot of you are talking about malware, and I love malware. That's really cool. But we are actually going to talk about virtualization today. Very intro into virtualization. So hopefully you guys are here for that. If not, well, listen to my soothing voice because it's probably not that soothing, but we're going to talk to intro to virtualization. We're going to specifically talk about a guide to setting up a basic virtual lab. So let's get started. Our agenda will be intro to virtualization. What is it? What am I talking about when I say virtualization? Why is it so awesome? It says virtual lab. I'm going to kind of do a virtual lab as we go through, and I'll apply it to some of the cybersecurity skills and why virtualization can help in progression into becoming a good cyber professional. That's those two virtualization lab. I'm doing that as we go and relating it to the cybersecurity skills. So first off, virtualization, just what is it? It's a buzzword, I would say. It's something that's been around for a long time, and it doesn't even really apply directly to cybersecurity. I would say it more fits into the world of IT. Now, here are a list of objectives. Specifically, we're going to talk about bare metal virtualization versus VMs, what hypervisors are, and different types of virtualization, really. We're going to discuss host-based virtualization, hypervisors, based VMs, cloud-based VMs, and eventually containers. Now, I will say, starting out, I am not going in depth into cloud or containers. That's outside the scope. One, it's called Intro to Virtualization, and that's just outside the scope of today's presentation. So I apologize. We can have a discussion on that at some further point, I'm sure, but I don't have time to talk about those, honestly, especially for keeping it simple. But we're going to talk about the differences between the different types of virtualization, the advantages for specific ones, and why virtualization can apply to cybersecurity. It says OS flexibility, training, security. There's a lot of really good things to get started there. So what is virtualization? So it comes in many forms. And way back in the day, in IT, we had to have one machine per device that we wanted to do. Basically, think about if we have, sorry, I'm reading this in the chat as I'm talking. That's probably a bad idea. But virtualization is really good. It was probably one of the pinnacle changing points in all of technology. It's what we went from, we had to have a computer that did, basically we had like 50 computers, one that did each machine did one thing. Then we're like, hey, what if we can make it simpler? Because think about that. We have to have 50 machines doing 50 different things. That's really, really expensive. And just maintaining that, we have to have someone going to 50 different machines doing the 50 different updates to those machines. And it was very time consuming, took a lot of energy, like power, the bill was very high, there's a lot that went into it. So virtualization came out and it revolutionized IT. Quite literally, it revolutionized it. So much so that virtualization is that we're virtualizing a network environment, or really system environment. We now, instead of having maybe 50 machines, we have one really, really powerful machine. And inside that one really, really powerful machine, we can host 50 or 49, whatever. We can host a lot of small or big fake machines. So realistic, though, that to a common glance, they look realistic. But everything about that machine is digital. There are no physical parts to that machine. They're all housed and they're all running inside what's called the application. I'm not going to get super in depth into that, but what's happening is these virtual machines aren't even real. Some of them are, in ways, as we'll discuss, are using physical devices and physical hardware, but they're all housed in really, really powerful machines. And we can, instead of doing 50 different machines, we now have one powerful that digitalizes a bunch of different machines. So we're going to talk about that. And it's going to all lead up into how can you create your own? What tools can you use to create your own? And I saw it in the chat. It can be used for cybersecurity, and it definitely can. And it's definitely used every day in cybersecurity. We talked about malware last week, and that's a great way. Put it inside the virtual environment, and that's definitely a positive. All right, so let's go into these, and we'll discuss as we go through the different types of virtualization. If this lets me change. All right, so bare metal. So virtualization is the creation of virtual rather than actual versions of operating systems, servers, of machines. It's really creating a fake digital machine. Virtualization is described as a technology in which an application or a guest-based operating system, you'll hear that a lot. A guest operating system or a digital operating system is acting like a piece of application. Virtualization actually began back in the 1960s. It was a way of reducing the amount of machines we had to have in an organization. And a key use of virtualization technology is specifically towards servers. We're going to show you desktop-based, so you can use it as you're learning. You can use it too, as I'll show you a couple different ideas how to use it, but realistically, it's used quite a bit in server virtualization. So we can have a lot of different server processes like web servers or DHCP servers, DNS servers, whole bunch of different kinds of things running. And we can protect them. We can back them up really, really easily. And they're all housed inside of one big machine. Hardware virtualization, or as we might hear it, platform virtualization, specifically refers to the creation of virtual machines, which is what we're going to talk about. The creation of virtual machines. This is basically these machines act and in all intents and purposes are real machines, but they're not. Remember, they're digital. So there are 4 types. We're going to specifically talk about 2 types today. So there is type 1, the native bare metal, bare metal or embedded virtualization. These are the hypervisors, more commonly referred to as. These are, as you'll see and we'll describe later, machines that sit almost exact on top of the hardware. There isn't really an operating system when we talk about Windows and we talk about Mac or Linux or BSD or whatever we're talking about. There is no operating system. It's the hardware and then this virtualization technology. This is very powerful, and we'll explain the pros for this. Type 2, what I'm going to, during our lab and as I walk through what I'm going to talk about there, type 2 is specifically host-based. So it's going to sit inside of a virtual, inside of an as you kind of see here, it is the hardware. And then on top of the hardware, instead of the hypervisor, we have an OS. We have that Windows or Mac or Linux or whatever it is. And inside of that, we have an application that's running the virtualization technology. There are pros and cons to both type 1 and type 2. But remember, all these machines, even though if I run a scan on my network and I pick these machines up, they look realistic. They're actually just sitting inside other machines. So this is another diagram, and I got plenty of diagrams because this can be very confusing to a lot of people. So I provided a lot of diagrams. But type 1 hypervisors, once again, we have the hardware, the machines themselves. We have those devices. And then type 1, referred to as bare metal, embedded, or native, is the virtualization or hypervisor technology. Then inside that, we have those guest operating systems. This is the second image that I'm showing you specifically. And it's, like I said, for those who haven't, the first image didn't resonate with. Then we have type 2. This is that host-based. Once again, we have the hardware, the host, so it could be Ubuntu machine. It could be a Windows 10 or Windows 11, which I updated to you, and I don't know if I'd recommend to you about Mac OS, whatever it is. Inside of that, then we've got the virtualization technology and then the guest operating systems. So like I said, there are actually other types of virtualization. We only have 2 here, type 1 and type 2. There's actually 4 types: host-based and hypervisor-based, type 1, type 2. Then we have cloud-based. Cloud-based specifically is type 3. This is ran in the cloud using basically a middleware, an automated platform that's running in the so-called cloud, a data center or a vendor. It's the way to access machines basically over the network, over the internet. Could be someone else hosted by, who knows, Amazon, or it could be hosted somewhere in our own local servers that we're accessing through the internet. Then we have containers. We'll explain containers, but as I said, cloud and containers, those are topics in themselves. I mean, we could spend hours upon hours just talking about each one of these. They are outside the scope. I do have a question that says, someone has the VirtualBox that's been used, and am I going to run a virtualization off of that so I can put it to use? Well, I am going to walk through setting up VirtualBox. That is the end goal, yes. But we are going to talk about it later on. There's other ones, definitely other ones out there besides VirtualBox, and those are the host-based. But that'll be getting ahead of myself. Right now, we're just explaining what that is. Then I actually want to show you and set up a basic using VirtualBox, a virtual machine, and go through how to use VirtualBox. All right. So host-based virtualization. What is host-based virtualization? As I said, it is the operating system on top of the hardware, and inside of that operating system is a hypervisor. It's a tool, it's an application that lets me digitalize one or more virtual machines. These machines look quite legitimate. And as I said, when you scan on the network, they might pick up as, hey, you've got a Windows 10 machine, or you've got could be a Windows XP machine if you're messing with that, or Ubuntu, or whatever it is. They're machines that look realistic, and they're actually fake machines sitting inside of this hypervisor. And I'm not going to go super in depth. We could go much more in depth, but I'm going to keep it high level. But they are utilizing the actual CPU. They are utilizing the actual memory, or RAM, as you'll more commonly hear me say it. And they do utilize the NIC, or network interface card, and the disk, so storage. These, even though they are virtual, they do utilize actual machine or actual hardware. There's just a whole bunch of layers between that using code and can utilize it in certain ways. The performance of these virtualizations is not equal to the operating system running itself. Usually, you're not going to get inside a host-based operating system. These virtual machines are not going to be as good as the host machine itself. If I'm running a Windows 10 machine, the stuff inside my virtual machine is not going to be good as my actual host Windows that I'm running all the virtual machines in. This will make more sense as I'm showing you and not just talking about all these layers of machines. I do have a question about what is a hypervisor. A hypervisor is, and it's a very good question. That's the layer, or that's the, as we refer to, the application for virtualization. It is the technology, the term we use for hypervisors, the term we use for virtualization. A hypervisor technology, or a virtualization technology, is sitting there at that level. At a high level, that's the explanation. So there are different programs, but this is VirtualBox right here. This is what this looks like. I might have all these devices, and I've got my machine running, then I've got a Windows 10 machine running, or in this case, it looks like Windows 7. And inside of my Windows 7, I have this program called VirtualBox. And inside of VirtualBox, I've got two machines, Ubuntu and XP, that, as you can see, are running. Well, I'm going to show you actually setting up and utilizing VirtualBox. It does, as it says here, sorry, I was about to skip to the next slide, but host-based virtualization is critically important. It helps us do a lot of things, even though, yes, VirtualBox is a hypervisor. And so even though it is host-based, even though it's not going to be nearly as good as the host machine itself, these digital or virtual machines, it is very powerful, and it can do really good things. It can actually help us be flexible. It can help us in a multitude of different areas. When they first came out, when virtualization first was announced, they were meant for servers. Even though they were meant for servers, it actually became at Linux-based organizations like Red Hat or IBM specifically, or other organizations that we might need. We might be running a Mac, or we might be running a Linux distribution primarily. Well, it might be like, hey, we need to run this Windows software. Maybe it needs to be Office 365, or it would, back then it could have been Windows, Word 1, whatever it was back then. And it was like, hey, we're running Linux, but we need this Windows program. Well, what we could do is actually, using our Linux machine, spin up a hypervisor using VirtualBox or another program. And then from there, we could run the Windows program inside of that virtual machine. And we'd still get the program done. We'd still get our job done, but we'd be able to go from there. So type 2 hypervisors are sometimes called hosted hypervisors. You might be able to hear that. Running on a they will be running on conventional operating systems like Windows, Mac, Linux, just like any other application. My virtual machines are going to run just like applications, just like my Google Chrome or my World of Warcraft, if I still played that, and other things. All right. So I'm trying to follow the chat, but I'm sorry, it's getting ahead. So I'll answer questions later. I apologize. So let's keep going. They are very flexible. As I said, when they first started out, they were meant for server editions, but they really helped us actually being able to run kind of like at Red Hat. Red Hat is a Linux specific operating system. It's one of the most popular in industry. If you're going to run specifically a Linux environment in your organization, it's going to probably be Red Hat for a lot of reasons. But even if you're running a Linux program, especially when it first came out, you might have to have Windows programs still running. Virtualization will allow us to do that. We'd have our host, in this case Linux, and inside that virtualization of a Windows machine, we'd run the Windows programs. All right, so there are examples of host-based virtualization. We have Oracle's VirtualBox, the one that I will be explaining and showing later. That is the free one. Then there is VMware Workstation. VMware Workstation VMware Workstation is free. There is a Pro edition, which I saw pop up in the chat, and it is paid. You do have to pay for it, or you should pay for it. That, and there is VMware Fusion. I believe the Fusion is the Mac version. Workstation is specifically for Windows. Fusion is for Mac. And I believe as of like a year and a half ago, they got rid of the free version of VMware for Mac. Don't ask me why. And I haven't verified that in a little while, but pretty sure they did. So you can get VMware Workstation. It is an alternative to the free VirtualBox. I'm not going to say which one. If you use it a lot, I'll explain this later on, I would recommend getting up to Workstation Pro. There is alternatives though. Windows Hypervisor. Windows Hyper-V is their specific one, and it does come part of Windows 10 Pro and Windows 10 Enterprise. So if you have either of those, you actually already have a virtualization technology running, and it's actually quite a bit better than it used to be. Up to more recent history, these Windows technologies could only really run other Windows machines. You couldn't run Linux or really anything else. That is fixed. I would say they're not as well documented for running really a lot of things, as well as Oracle's VirtualBox or VMware Workstations or Fusion, but it is possible. I've done it. I know other people that have, but often we're like, just because we're tired of not having documentation, we switch to one of the other ones. It is possible though. Other ones that I know of are FreeBSD Beehive. That is another one. It is free, but it is specifically command line only, especially start out with. There are different levels to them. Each one has its own specific reasons to use it. In my opinion, when you're first starting off, definitely use Oracle's VirtualBox. That will we use as an instructor here. I do use Oracle VirtualBox. When I'm with students, the students use it and learn it. It is one and it is great. And as you learn one, it really helps you learn all the others, because the technologies, even though they might be programmed differently, are going to be very similar. And a lot of the stuff I'm going to show you about utilizing VirtualBox, it is going to be maybe how to do it is different in VMware or another Hyper-V, that technology is most likely still going to be in that other one. It's just have to do it a little differently. Those are host-based virtual machines. Host-based specifically sits on the host. So it's the hardware, then the operating system, and then on the operating system, installed just like any other application, is the hypervisor technology. Then we have server-based, type 1. So host-based is type 2, server-based is type 1. And as you see here, it doesn't have pretty pictures, especially to start out with. Hypervisor-based virtualization is very important. It enables our host to run many, many virtual machines. The downside of host-based technology is that I have to use a lot of my machine resources to run Windows 10. So I have to take recommended 4 gigabytes or required 4 gigabytes of my RAM to run Windows 10. And I think it's like 20 or 60 gigabytes of storage to run Windows 10 or more. And I have to have a couple, like I have to have my RAM, my CPU, and my storage. All I have to take away from possible virtualization to give to my actual host machine. Well, in server-based, I don't. There is no operating system. There is no Windows 10. It's actually just hardware, hypervisor. I installed a program. Instead of installing an operating system, I installed that hypervisor technology. And from there, this is what I get. As soon as you boot that hypervisor up, it looks very similar to this. Now, it does depend on which one you use. There are a couple different ones, but they all look pretty similar, in all honesty. And it's a command line interface. And really all, you can do some basic configuration like basic usernames, basic IP addressing. But the main purpose of this is just to get you an IP address, to get it on the network so that you can eventually access it from another machine who does have a desktop environment on the same network. Because this is what it looks like. Once I set a server-based hypervisor up, it's going to give me this screen. Really, it's going to be very similar to this. It's going to say, here, go to this IP address. And if you want to log in here, you can, but really go to this IP address from another machine on the same network. And once you do, this is what it's going to look like. You're going to have, I mean, it's going to be a little newer version of Proxmox than this, but you can do this and it's going to have, if you can see here, there's a list of different IP, different virtual machines, 102, 104, 106. Don't know why they named them like that, but they did. And then what they do, different specifications, the users on them. You have to access, it's called a browser-based or a web-based access. So you have to access it through a browser, the configuration through a browser or a web interface. It was asked, are all based on Intel? You don't have to use just Intel. I actually run a lot of mine on AMD. Professionally, I would say enterprise, especially server grade, specifically server grade operating, server hypervisors. Yes, a lot of them do run on Intel. It is possible to run on AMD, but yes. It says host-based hypervisors also introduce a larger potential for attacks. Yes, they do, and we're going to actually talk about that. They do provide a larger area of attack, and which later on we'll discuss that. But yes, that was someone said that in the chat. There are reasons for one versus the other. But the main thing to realize is host-based. One of the advantages is I can turn them off as I don't need them. They're there if I need to play with something, they're there for me to play with. I don't have to get other machines. But I do have to take resources away from my main machine or from any possible virtualization and give it to my host-based operating system. On the flip side, kind of going back to what this first slide on, if I can get back, this first slide on server-based hypervisor says, this allows a server to utilize most of its resources. So most of the CPU, almost all the RAM, almost all the disk storage space for virtualization itself. So instead of giving 4 gigabytes of RAM strictly to my Windows 10, which that's, I think, the recommended, but it's really like 6 or 8, you can give it to your virtualization. I can have even with 4 gigabytes of RAM, I can run at least 4 Linux virtual servers. If I run them really lightweight, I can run more than 4, especially if I'm running a really good CPU and have good storage. That's definitely plausible. Should I? Maybe. But there's a lot of benefits for both. Now, server-based, you do have to have a machine that is more powerful. And you have to have, we're going to get into it, but you probably want multiple network interface cards and some other stuff. Home labs, you're going to want to start out with at least the host-based environment. But the advantages are there. There's advantages to both host-based and host-based and host-based and server-based. Now, I did want to say, actually on the slide, so I'm glad someone brought it up, host-based does provide security issues. You are adding an extra level in. You're adding a whole nother operating system in there that quite often from my experience isn't watched as well it should be. It is said that it gives us a greater attack method. It gives us extra places for breaches. It gives us a lot of more things to update. Without getting really into the details, it gives us a bigger footprint to attack. So there are different mechanisms. Now, the footprint doesn't have to be there if I never run them, or I'm only running them as tests and turn them off when I don't need them. There are pros and cons to both. So what it really realistically looks like is I've got here 3 different servers. When I scan my network, this is what it could look like. I could pick up, oh, you've got 3, maybe even 4 servers running, when realistically, I only have actually 1 machine. And inside of that 1 machine is 3 virtual machines. If I went physically to that office, I'd be like, oh, there's only 1 machine here. But if I looked at a network diagram, I might see 4. I might see the hypervisor for this and 3 other machines that look like they're just sitting on the network. All right. So there are pros and cons to this. Now, there are a lot of technologies. Here are the most common ones that I could pick up. Some are free, some are not free. Proxmox is the one that I showed you. Citrix and XenServer and Proxmox, I believe, are 2 free ones. Windows Hypervisor, that comes with a Windows server. So if you have Windows 16, 2016, 2019, 2012, whatever it is, if you have a Windows server, it's going to come with Windows Hyper-V. Then there is also a VMware option. So when I said VMware, they have host-based options. Well, they also have server-based virtualization options. Oracle does have VMware as well. Does have server-based virtual machines. They got Spark and x86, which I believe is specifically for 32. I haven't used either of those. Professionally, I have used Windows Hyper-V and ESXi, but I haven't ever. Actually, I have used Proxmox in a couple organizations. I didn't install them, but I have not used these Oracle ones. They are there, and they're out there, but there's a lot there. Now, Proxmox, I know this one specifically because it's an open source one. If you want to stick to open source, Proxmox is a good option. XenServer is also there too. I believe XenServer is open source. Someone can correct me. I've always gone in Proxmox realm. So then we have cloud benefits. So cloud is another type 3 virtualization. There's a lot we can do with cloud. And when we talk about cloud, almost in the security world at least, when I say, well, what is cloud? The number one answer is someone else's machine. And that's really what it is. It's usually if I'm connecting to someone else's machine to do some kind of task. Now it has evolved. There's a lot I can do with it. There's different types of cloud technology. Some are for application-based. I can do an entire network environment in the cloud. And when I talk about in the cloud, it's accessing machines or applications now, specifically through the internet or through the network. Instead of being directly in front of them or connecting to a virtual machine directly I'm connected to on the same network, it could be connected to on a different network through multiple firewalls or different areas. So that is cloud. Cloud does have good benefits. because it is hosted by someone else. When I say it is someone else's machine, you're really connecting to someone else's virtual machines, probably almost definitely running, unless they set them up incorrectly, someone else's server-based virtualization that someone else is running, and you're connecting yourself or your company to that. The benefits of that are they're most likely always up, or you're signing some agreement that if they're down, they'll get them up at a certain point. Instead of having your own IT department running them and maintaining the costs, they're maintaining the costs, they're maintaining off-site data store, productivity. You can access these from most places if you set it up that way. They're easily upgradable. There's a lot we can do with cloud. Security, you'll actually find, I would say in security, some people are all for the cloud because it can be really well secured. Other people are like, nope, no cloud, it's someone else's machine, never touch it. It's funny. And so I'm not going to say which way or the other. Like I said, cloud is outside the scope of this talk, but it is an option. So it does help us. Cloud advantages. You can access it. This one specifically is Microsoft Azure or Azure. It helps a lot of stuff. As you can see, there's a lot of things. We can actually have Azure container services, combining, do collaborative. There's a lot we can do with them. They provide more than just connecting to a machine now. They provide connecting and utilizing applications, utilizing an entire environment. There's a lot cloud can do. Cloud does have a benefit. As you can see here, it does have a measurable benefit that average improvements in time to market. We can get things up faster. We can get them maintained better. It can reduce, and it does honestly reduce the IT costs in the long run. But yeah, so there is benefits. If you want to look at that, we can have another topic, or you can go research that on your own. There are cloud providers out there. I named the big three: Microsoft Azure or Azure, Amazon Web Services, AWS is more commonly what you'll hear referred to as, and Google Cloud Platform. Three of the biggest ones. Then there is containers, type 4. Containers is a beast in itself. It really is. It is type 4 virtualization, and really it is, it's a whole thing. As you can see here, we have hypervisors here. This is the normal one we have. And we have, this is a host-based operating system, or virtualization. We've got our devices down here, our actual hardware level or layer, as you'll hear it. Then we've got our host operating system, Windows 10, Ubuntu, Red Hat, Macintosh, whatever it is. And then on top of that, we have our hypervisor. And let's just say VirtualBox, that's the one I'll be showing. And then inside of VirtualBox, we have 3 different virtual machines. And these 3 virtual machines are virtual machines by themselves. Literally, this is virtual machine 1. It acts and looks like its own machine. We've got virtual machine 2. Acts and looks like it has its own configuration files, has its own fake virtual network card. And machine 3 completely has its own host name, has its own users. It's its own standalone machine. Containers, very high level, is different. So it does still have an operating system. You do have to install it like an application. It has the device. So it's got your hardware level. Then it has an operating system. Primarily, I would say Linux. I've seen it ran in other environments, but almost 9 out of 10 times I've seen it on Linux. So we have it in primarily, then it's Docker. Docker here is our Docker engine, is the container program. I think someone asked earlier if Docker is the container. Yes, Docker is the most common container technology. And then we have the Docker engine, and it's like directories. Instead of having it stand alone, we're running this, and we can kind of manipulate it to make it so they can access different ones at a very high level. Instead of making them so separated that everything about this is completely separated, like we do with virtualization, they're kind of related. They can sort of utilize similar spaces, but they're still their own standalone, and they can test applications and do other things. It is a newer technology, and it is, trying to think how to high level say this, but it's a really powerful thing, and it helps us with reducing RAM and CPU costs, and not having to get into a whole bunch of different machines to configure them differently. It helps us configure things together and similarly, and why we can still make them different. They can control them in one place. Very powerful there. It is a newer technology, and it is, especially in the, I'd say in the developer world, it's booming. Honestly, if you're not running Docker and you want to be a developer, go learn Docker. In the security side of it, there are a lot of concerns. You're connecting a lot of machines, you're doing a lot of things, even more so than we talked about with security concerns for host-based. I would say this adds more. I will say I don't have as much. I'm not a developer. I have used it. I've used it in a couple of different areas. It's not my cup of tea. I do see the security implications, and I just, because I don't have to use it, I don't, unless I'm trying to protect something. All right, so that is the types of virtualization. I see a lot of people that are saying, can we talk about VirtualBox? The answer is yes. We're going to talk about VirtualBox now. I've got a good amount of slides here, and I think I'm not looking at time. We got time for it. So let's go through this and look at it. I've used about 45 minutes for that. So VirtualBox hardware requirements. Hardware, so these are the actual pieces of hardware you have to have on your host-based machine. Requirement, I apparently didn't put a CPU, but I would say a newer i5 at least, 8th gen or higher in my opinion, or an i7, similar AMD. I would have AMD, you could have 7 on 5. I would say AMD Ryzen 7 or higher. You're going to want for a nicer machine. You can run this on older, but I'm not going to get into what CPUs and RAMs storage really does, but you're going to want a somewhat powerful machine because you are really virtualizing. You're using actual machines to try to run processes. The CPU is the central processing unit, so it's still got to run its own Windows 10 processes at the same time it runs your fake machines processes. It's not, hey, I'm going to run my virtual machine, the Windows can turn itself off. No, it's still got it has to run the Windows machine, and on top of that, it has to run those other machines you're going to run. So you still have to have good there. Then RAM, 8 gigabytes or more. I recommend 16 or more. Can I repeat the AMD CPU? I would say AMD 5 or 7. I'm trying to think. They just blanked me on the ones 2800. Someone can look it up. I'll look that up. I'm blanking on all CPUs right now. Apparently that's why it's not there. But AMD, a newer AMD, Ryzen 7, 5, 7, or 9, really, and it wants to be, it's been made in the last 3 to 4 years at most. And I'm trying to think of like actual models of that or gens. But so RAM 8 or 16, and then storage at least 256. And if you have 256, you're not going to get a lot. Truthfully, you're going to want, in my opinion, 512 gigabytes or a good terabyte is a good starting point for virtual machines. You're going to realize pretty quick as you're testing with these, virtual machines can really go up. OracleBox should be able to run on a Raspberry Pi. No. New will not run. I mean, you might be able to get it to run, but it won't do anything. And I doubt it's actually built for the ARM chip. So no, it's not going to run on a Raspberry Pi. Raspberry Pis do not have enough power for that. All right, so what do we need systems-wise? This is easy. VirtualBox is actually, it's not the most powerful or the most compatible. I mean, it's not, after an update it might break and there's some weird things. It is open source and it's free. That's the thing. That's the catch. It's free and it's open source, and it's actually comes with updates all the time, but it's known to wait. You kind of learn to wait to update VirtualBox until someone else has. Just don't update VirtualBox until you read about it on Reddit or Spiceworks or somewhere, and someone tells you all the fixes for what it broke in the latest update. It does have a lot of updates. I'd say like once a month or every few weeks there is an update. It is updated quite a bit and it's maintained, but it is still free. The nice thing about about VirtualBox, Oracle's VirtualBox, is I have not run into any operating system it does not run on. I've tried many different operating systems and it's run on all. As long as the machine itself does have compatible or does have good technology or good hardware. What you're going to need, you are going to need the VirtualBox install file. You're going to need the VirtualBox extension pack, and I'm going to tell you what those are. And you can both download them from that link, and I'll show you the link. That's literally just me Googling Oracle VirtualBox downloads. And it says, hey, come to my download page. And the next slide has a screenshot of it. You're going to want both of these. And I'm not going to walk you through. There is a recording of this. My slides will have instructions on them. I try to build it that way. So I'll go slower as I go through the next few slides, but I will give you a warning. I'm not going to wait for you to follow along. So VirtualBox installation. It does work on almost every operating system, which is really, really, really cool. And it looks, after it's installed, it looks almost identical on every operating system. There are some key features, but it looks and acts almost identical on every operating system. For Windows, even though it says click OS X here, it should say click, as I've highlighted, Windows host here. All right, and you download that. You just click on it and it starts to download. Double click the file that it downloads. It'll be VirtualBox dash, it'll have a whole numbers, and it'll be .exe. Click on that and you're wherever it downloaded to. Double click on it and just click next and yes until it's done installing. That's that easy. And once it's finished, just go to your start menu on a Windows machine and you should see an icon for VirtualBox. It should be, if you're on Windows 10, it'll be under your most recent installs if you have that setting open. If not, scroll down to Oracle, or if you don't have folders enabled, go down all the way to VirtualBox and it'll be an icon there. VirtualBox will be installed. If you need, go to the Windows page and it's the first one. For Mac, it's actually, and I have the right operating system here, click the OS X option, which is right there, and start the download, just like the first one. Then double click on the downloaded file, which is a .dmg file. After that .dmg file is basically all the way downloaded, double click on it, and it's going to open this window here. And it's going to say, hey, what do you want to do? And it'll tell you even steps, the nice Mac user friendliness. Double click on the .pkg, which is the package file, and that's the installation file. And every time you want to access it on a Mac again, it's going to be under your applications folder, which you can access right here. Click through the installation, and after it's done, click close. It's that easy. It does, after the installation, ask you, do you want to move the installation file to the trash? Say yes. Or no, you don't have to. If you want to ever install it, it does come with a pre-built uninstallation tool. And so if you just want to keep it, you can, or just copy that to that application folder, you could. All right. So you can install it on other machines. I'm not going to show you how to do that. That would just be too crazy. But it really works on many operating systems. After you install it, you're going to see basically this screen. Or actually, yes, after you uninstall it, sorry. After you download it, go back to the web page and download the second one. It's on the same screen. This is the download page. Download this one, the extension pack. Get this. And it's compatible on every operating system. It's literally the same file for every operating system. Double click on that. And after you double click on it, it's going to give you a window that looks like this. Click install. Good. It's going to give you, this is basically, this is an extra, it doesn't come with VirtualBox in case you don't want it. But especially when you're doing labs and you're doing testing of machines and you're really starting to learn, it's really helpful. It helps with adding USB capabilities. It helps with, RDB, if you want webcams inside of your virtual machine for some reason, if you want to do copying and display resolutions, it really fixes a lot of things. It's just always a good thing to have. And please try to keep, if you're running this, keep the chat related to, as it says, keep the chat related to on the topic. So let's keep going. So I want to get to the actual core of this. So this, after it's installed, and I have the extension pack, you won't see the extension pack anywhere. After it's installed, it'll just be in the background. The configuration manager, this is it. I'm gonna keep saying, go to your VirtualBox manager. This is it. This is the home page for VirtualBox. Everything, as we install more virtual machines, they will be on here. This is what it looks like on a Mac. And it's going to look almost identical to this on a Windows. And if you're on Linux, it's going to look very, very similar to that. The SD machine look very, very similar to that. Doesn't matter. This is the home page. This is really where you manage why it's called the VirtualBox Manager, every virtual machine. Now, I know I only have 30 minutes kind of, so I'm going to try to go a little faster, but I do want to actually show you this. So I provided steps. I have provided steps for every single thing. So after the session, because I know this is recorded and we're going through this, I'm going to walk through this. But afterwards, you can take these slides when they're sent out, because I hope they're going to be sent out. If not, they're on the screen, so you can just read them off the screen, the slides, and you can go from there and read the instructions, which is pretty helpful. I'm going to walk through these instructions right now. So VirtualBox setup. First one. Here's all of these, but I'm not going to read through them. I'm just going to show them. I'm sorry. I'm lazy and I don't want to read off my own slide that I spent a long time writing. So let's get into this. All right, I apologize. I'm going to share my entire screen. So there is a slide, my slides in the background. All right. Here is my pre-filled out one. Just ignore these folders. I'm going to set up a new one. So when you first access VirtualBox, minus these three, it's going to look identical, especially on a Windows machine. Now I'm on Windows 11, so it does have the nice little rounded edges for some reason, but it's going to look identical to that besides on the Windows 10. So what I do, if you see, click new in the VirtualBox Manager. Cool. I'm going to do that because Eric's awesome. And I will write whatever name I want for my virtual machine. Now, this name does have to be different than any other virtual machine you've already made. So if you're someone that's in the chat that's like they're trying to set this up or they've been messing with it, and they've got old machines that might have done wrong, delete all of those, or make sure you don't name any of the new ones what you named the old ones, or it won't work. It'll give you a couple errors. So here I'm going to say server Ubuntu server, and I already have a server 1 and 2, so I'm going to name it 03. And this is, I can set up where do I want this saved, and I'm going to say right there. It'll automatically switch to Ubuntu 64 because I gave it the word Ubuntu. If it doesn't, or I'm not putting the term in it, and it might still say Windows. Well, that's weird. It'll be like, oh, you're running Windows? No, I'm trying to install Linux here. So I have to go and choose them to make sure they're getting all the right information. There is Microsoft Windows, Linux, Solaris, BSD, IMB, IBM, Mac, and other. Not going to go through those. If you don't know what those operating systems are, there's some really cool ones there. Go check them out. You can mess with them. You can create virtual machines about them. And there are a lot of different new Linux ones if you want to know what they are. But now I'm going to say memory size. Keep it at 1024 until you know what you're doing, especially for Linux. If you're running it and you want it to be faster, give it more RAM. If you don't care about how fast it is, or you're not going to have a desktop environment or a GUI, you can keep it lower. I'm going to keep it at 1024 because I want to save RAM. Because remember, the more RAM I give it, the more it's taking away from my host-based operating system. That's the big thing. The more I give it, the more it's taking away from my Windows. And my Windows has, now I'm using my nice machine, which has 32 gigabytes of RAM. But if I had 8 total, I'd be taking a full gigabyte away from my Windows machine already. And I'm going to show you that. But if my Windows has 1, I'm taking another one, or 4, taking another 1 away. I only have 3 gigabytes left to run my entire machine before it crashes. So that's not good. So the more RAM, the better. All right, then just click create. I don't have to worry about these. Literally, it's good. Just walk through with the defaults and hit next. Dynamic, yes, you want dynamic. You can read what they are later on. I tried to put what they are in the slide notes once you get them. My recommendation is don't keep this at 10. I think Ubuntu requires actually 20, but 40. And that's a big thing. It asked me, how much storage space do you want to make this file? And I said 40. The nice thing about that is if you said dynamic earlier in that configuration, it's actually going to say you can take up to 40, but to the machine itself, it says I have 40 gigabytes of storage. Well, really, it's only using 5. So the machine's only going to give it 5, but it'll take up to 10. Question is it better to use SSD or HDD for VMs? If someone answer that in the questions? If they don't, no one does, I'll get to that. You can use whatever, but someone else I'm sure can answer that. Then after, you can see this right here. I have this new handy dandy Ubuntu Server 3 right there for me to go. And I completed all the steps on my slides. Now let's keep going. So I now have in the VirtualBox Manager, let's look at some of the things. First thing, before you turn it on, please don't turn it on immediately. One, because that's not what I'm doing. And if you're following along, you did it wrong. And two, there's some things I want to show you. So right here, I'm going to highlight this Ubuntu Server 3 because that's the one I just created. Then I'm going to click Settings. So click on Settings, and then you can click on different things. Now, my slide specifically says Network Settings. Set up the network. You want to make sure you have network access because when you install your Linux machine, it's like you want to install the latest updates. If it doesn't have a network card attached to it or a digital network card, it cannot install any of the updates. So let's click on, so I clicked on Settings and then Network, and I made sure that Adapter 1 is enabled. This is, if you're familiar with hardware on a machine, the network interface card, that NIC card, that wireless card for Wi-Fi, or that machine, that open slot on the back of your PC or on the slide of your laptop that you plug an Ethernet cable into. This is me digitally doing it. This is the setting for me doing it digitally. And if you look at me, I am pointing at a random thing where I have my slide. But I'm saying attached to NAT. Just do this. If you don't know networking, go look up what NAT is. It's outside the scheme of me in the slide telling you what it does. But basically, this gives me internet inside my virtual machine. And so change it to that because it'll do it automatically. It says, were we supposed to set up a Linux OS? You don't have to. You can later. You can do it. I'm going to show you how to do that after. Like if you're asking, hey, when do I set up the Linux OS so I can build my VM? Come in slides. If it's, should I have done this already before the presentation? The answer is no. You could have downloaded it or just watch me and do it on your own later. So I'm going to change that, make sure if it's not enabled, enable it to look just like this, and then click OK. Once again, it's going to look identical no matter what operating system you're running on. Then I'm going to switch. It's going to look just like this picture to the next slide. And I have it explaining what each of these are. So general, this general tab gives me basic information like name and like location of where it's stored on my machine. Then system, change the RAM, CPU, and bootloader if I want to go to the systems. Display, settings for monitor, remote desktop protocol, and boot order. Store display, yeah. So if I do remote desktop and stuff like that, storage, where I set my storage, my hardware disk, and CD setup. So that's actually where I would give my fake CD-ROM so I can install Ubuntu, and I'll show you that. Audio, well, that's where I'm going to do my audio stuff. If I want sound in my virtual machine. Network, where I configure my network, kind of like I just did. Serial ports, if you want to have a fake serial port connection. USB, if you want USB connections. I almost clicked on this. You can't because it's a virtual machine. So let's show you that real quick, because now it's going to say, hey, let's start the machine. Well, there's a step that I missed, and I want to show you that now, probably because I couldn't figure out how to word it on my slide. So let's go back into my virtual machine. So here, I'm going to want to go into settings, click on settings, and I've got this up. Now I have given it system. I've given it 1024 megabytes total. This is going to mean it's giving it a full RAM of full RAM of one gigabyte of RAM. Now that's great, except if I'm installing a machine, that's actually going to be kind of slow. Really, really, really slow. So what I do is my Linux machines, especially when I'm running them as a server, will only need maybe 512 megabytes or a full gigabyte, not a terabyte, a full gigabyte to run. If it's only running like SSH or a web server or something very, very trivial and very basic. So I'll come back in later, but I have this right here, and I'm going to say 4096 just to give it 4 gigabytes of RAM. If you don't have 4 gigabytes of RAM spared, don't do this. But I'm going to make it faster because I need this to go faster for this slide. So after I've done that, you can see all the different settings, systems, display, storage that I talked about. And this is one last thing. I'm going to click OK and click Start. Now I was asked, hey, where's that Linux? When did you set up the Linux machine? I haven't yet. And it's going to pop up on my wrong monitor. This cool pop-up right here. And it's going to say, hey, you're trying to start a machine, but you haven't installed anything on it. Do you have an ISO file or an image file for an operating system that you want to install on here? I'm going to be like, well, yes. Let me tell you where it is. I've already got them set up, but if you don't have them here, you click add and you go onto your machine and tell it where it is. I already have it, so it's going to pop it onto here. And I'm going to say Linux server, just to make it quick. Actually, I'll do on that one. Choose and then start. And it's going to boot up. It's going to go and it's going to run. And I'm going to have it run in the background as I'm going to not have to wait for it. But it's going to keep running and it's going to walk through the Linux install. This is not, I just don't have time to walk through an entire Linux install. If your questions are like, I don't know how to do that, just keep hitting the next button and it'll actually do a lot of it for you. And I'll come back to that Linux machine that's running in the background, but really just keep clicking next until it pops up with the screen, which says, hey, restart, I'm done. It will ask you for, hey, what's the name of the machine do you want? Or what's the username? What password do you want to give? Just fill those out. Don't forget that password. Even give it a password. Don't ever forget that password or the username, and you'll be fine. It's going to look and work. All right. So after I've done that, I'm going to have this. Let's go back to my, let's see, it's going to look and it's going to show you that, hey, I've got a Windows or I've got a new Linux machine right here. And it's going to be like, hey, we should be good to go. Is there a Mac OS ISO? And the easy answer is no. It's proprietary. And they don't like giving out ISO files. So what's happening here is after I've got it set up, there are some things you're going to want to do. The first thing I recommend, as soon as you're done install, literally as soon as you're done, it says, let's restart. You restart it, power it up, and then turn it back off. Turn it back off so you can clone and take a snapshot. This is very, very important. And I highly, highly recommend you get in the habit of this because you're going to need to get in the habit of this. Cloning is creating a full clone, like a duplicate copy, exact duplicate copy of that machine. So if that machine goes down, you can restart that clone and it'll just restart from basically everything you've done since that clone is going to be gone. But you have a full machine with everything you've installed onto it, a brand new Ubuntu, brand new Ubuntu Linux set up, ready to go right there for you. And that's the clone of it. It can help with a lot of different things. Backup is key. I can't stress that enough. Backing it up. That is a technology that's going to be on every virtualization technology. Cloning and snapshot. Cloning is literally making a full-on copy of that clone and storing it as a giant file somewhere off on your system. Then snapshots. The easiest way I found to explain what a snapshot is to say it is like a save file in any video game you've ever played. And if you haven't played a video game, it is basically a place where if in the game you mess up, something goes wrong, well, you just go back to this file and it's going to restart from where you last saved. It's literally just going back to maybe when you, like a picture, it's a snapshot. You go back to when you take the picture and everything that you've done since then is null and void, and you just restart from that place in that save file. That's key, because then if you can make a whole bunch, just go back to maybe one every day or one every week. Oh, everything messed up, go back to the last snapshot and, oh, that virus is gone. Or, oop, whatever I installed that ruined my machine, nope, that's no longer here. Okay. So a snapshot is basically a place on that specific VM. A clone is a separate VM, if that makes sense. So a clone is a completely different file that it's a duplicate, or however many clones you want to make. It's exact duplicate, but its own system now. It's its own thing, but it's a duplicate of the machine when you first made it. A snapshot is just a placeholder, basically. A place that's a save. It's like, hey, this is what the machine looked like right here. If something goes wrong, let's go back to that one place. It's not a separate machine. It's nothing. It's just a snapshot. It's literally a spot in time. All right. Then let's actually go back in this. So I think I missed something. Cloning, yeah. Once we have that Linux machine running, let me show you. I've got that Linux machine running here. So I've got my Linux machine and it's great. Let's fully clone it. Let's say, all right, I'm going to do a clone just to show you. I'm going to say generate new MAC address. That's key. And those are the instructions on the slide. I'm kind of trying to go faster to hit that time. But generate new one and just hit next. Full clone, just like I said. And it's could take a little while. Now, I haven't done anything. There's nothing on that machine and I still have 4 GB of RAM. So it went pretty quick. It might take a long time. The more stuff you have, the more files, the more things on that machine, the longer the cloning process will take. But now, as you see, I've got 2 different machines. I've got one that says Ubuntu Server 3 and another one that says Ubuntu Server 3 clone. So let's turn them on. I'm going to double click on them to turn them on. And it's going to say, oh, you're starting this machine. Well, it's starting the first one. And here's the second one. It's not giving me the right option. Actually, the reason it didn't work is because I cloned without installing. Let me clone something that has already been installed. So for this event, I actually already did it. I have this one right after the install, this Ubuntu server right here. So it says, all right, I've installed my Ubuntu desktop right there. And then I did the server, I did a clone on it. I'm a clone and made this clone right here. And it's going to open a second one. Somewhere, there it goes. So I've got a clone right there. So now I've got 2 virtual machines literally running and on top as I'm talking. These are running, turning on, and they are running Ubuntu in the background. They're starting up. It's going to be a little slow. I think each of them only have a gigabyte, so it'll be a little slow. But you can see now it's saying password. What's your password? Right there. Let's go to the other one. And just wait a little while, let it turn on and click on it. All right, and it's going to give me the first message. This is what you see the first time you log into an Ubuntu machine. I'm going to say, yeah, whatever, just get off my screen. Next, just click next and then done. And then I've got this here. And then there's a reason I'm doing this. Terminal. Now remember, these both have that NAT setting I set up with my network. And then I can type in, let's see, IP to find my IP address. And it gives me an IP address of 10.0.2.4. All right, so let's look at this other machine. Terminal. IP-CA, oh, and it also has the exact same IP address. Now you might think, oh, it's a clone, so it's literally has the same IP address. That's not actually it. The reason it has its own IP address is it's its own network. Each of these machines are in their own little place by themselves, isolated from the rest of the world. That's it. I need these machines maybe to talk to each other. Maybe I want to set it up so I can run a web server, maybe a website on one machine and access it from the other. Maybe I want to remote into this machine from this other machine. Maybe I want to have a virtual router and set up a virtual network to practice networking. Well, I need these to be on the same network. So how do we do that? A couple options. First is, let's go back into, I'm going to minimize those and go back into my VirtualBox manager, if I can find it. Because now I've got a whole bunch of stuff started up. VirtualBox manager. All right, here it is. Now you can see in my VirtualBox manager, I've got 2 VMs started up. So let's click on the settings for one. And you can see a lot of these are highlighted out. A lot of settings in here cannot be done when the machine is running. So I need to go in and I want these to talk to each other. There's a couple options. I could put them on their own internal network and it'll be a VirtualBox kind of running everything, but putting them together. I could do bridged network. A bridged adapter is basically me putting on the same network as my host machine itself. Yeah, it's on the same network as my host machine, which might be why it's there. But then you're making it a real machine, you better secure it like a real machine. NAT is how I had it, kind of separate them under their own network. NAT network is what I want to do. So I want to create a NAT network to make them talk to each other. By default, you can't. You have to go to preferences, files, preferences, they're on the slide behind me. And then you have to say network, and then this isn't going to be there. Let me remove it. I'm going to say, I want a NAT network. I just click this green option. Let me show you again. This is what it's going to look like when you first spin this up. Reasons are here on the slide, but I'm going to click, I want a NAT network. This means I'm going to use NAT, but put both of these machines on the same network so these can talk to each other. And then I'll click OK. And once I do that, I'm going to go back into the settings for each of the machines and say, hey, go to NAT network. And oh, it named it. This is the NAT network I just created by clicking two buttons that are on from file and preferences. So I went to file, preferences, network, create a NAT network, and I had to do the same thing with the other machine. All right. So then I put it on a NAT network. If you want to see, my details will say, yep, NAT network, it is on the NAT network. Let's click on the other one. This one is called Ubuntu Desktop Clone Desktop Disk 1. It is also on NAT network. Okay, so let's look at this. Look at the slide, and it tells you how to do that. Why? Why do I want these two machines on the same network? Well, there's only so much you can do with only one machine. You can learn the basics of Linux, but you can't really do a lot of networking stuff because there's nothing to talk to. Networks is all about making machines talk to each other. If I don't have another machine to talk to, I can't really learn a lot about networking. So let's try to make these two machines talk to each other. That's the lab. So ignore that because that's for later. I'm going to try to make these two machines talk to each other. So I've got one machine here and the other machine there, and let's try to do this. So now I'm going to do IP-CA and see if it's got a new IP address. Well, it says that still says 10.0.2.15. Sometimes it'll automatically find, oh, but this one right here has 10.0.2.4. Well, let's see, can it ping 10.0.2.15? It can. And let's check from this other one. Can this one ping 10.0.2.4? It can. So what does that mean? It means now these machines are able to talk to each other. I now have two machines inside of a virtual network that can talk to each other. And from my Windows machine, by default, let me open the terminal on my Windows machine. This is my new Windows machine. If you're unfamiliar with the Windows 11, this is the new terminal. I'm going to try to ping those machines. 10.0.2.4, no response. By default, these are on their own network. It'll say destination host unreached, because these two machines are in their own secret kind of network where I can do a lot of stuff. I can make a third network or a third machine, put it onto that network and keep going. So why might I want to do this? Why do I want machines? What do I do with them? Well, like I said, you can practice networking. Do you understand routers? I mean, you only can go so far in cybersecurity without the understanding of what networks and systems are, which is probably why you're here, so you can learn the technology to learn that stuff. Great. Use this. Get this set up so you can start learning the basics of networking, the basics of Linux and the command line. What was that command I just ran? Opening the terminal. Maybe you want to learn how to sniff networks. Maybe from one machine using Kali or another Linux or even any tool. Sniff or watch the traffic from other machines on the network. Maybe you want to set up different servers, a DNS server, a DHCP server, a Pi-hole, which is a Raspberry Pi. It's a program. It doesn't have to be on a Raspberry Pi. Someone asked about Raspberry Pis. That tool, Raspberry Pi or Pi-hole, what that is a DNS blocker or kind of black hole. It's an ad blocker, really. That's a technology that can be installed on anything and not just a Raspberry Pi. So you can put that inside of a virtual machine, that technology, not the Raspberry Pi, that program. It's called a Pi-hole. Or any ad blocker. Put that inside of a virtual machine. Try to get that running. Maybe create a testable, vulnerable machine that you're trying to break from one machine, break into that vulnerable machine. Maybe you just want to try out a different operating system. Honestly, it's endless. Having one machine is a great step. Get a second machine. Get those machines to talk to each other. Actually understand how they're talking to each other. How did they receive their IP addresses? Figure that out. And you can do that now inside of a machine. Questions? That is basically everything I have for you. We got 10 minutes left for questions. Questions. You'll get the slide deck so you can go through the notes, through the instructions that I put on there for setting everything up. Questions?
I do want to show.
So I have a question. Yes.
Just a quick. Let me just show a quick slide if it will pop up in case we lose anybody in Q&A. We do have an event tomorrow for Cybersecurity Awareness Month continues. So we are going to be hosting Intro to Cybersecurity certifications. So we're going to have Scott, who's a senior career coaching manager at Flatiron School, and Syed, who is a instructor at Flatiron School who holds, I think, 10 or more cybersecurity certifications, talking about kind of their recommendations, what makes sense for your career. So I'll send this link in my recap email, but just wanted to make sure if you want to spend some more time with me tomorrow, we will be here. All right, sorry, Eric. I think you're muted.
I was muted. I was trying to let you talk, and but I have a question here, and it says, what's the difference between an OVA and an ISO file? That's a really good question. An OVA file is an open virtual appliance file. Basically, it's a pre-built virtual machine. Versus an ISO file is the install file or the image file of a machine that you will be creating yourself. Is kind of the simplest terms that it is. In the olden days, you probably might have seen these old Windows 95 floppy disks, or like an old Windows XP or Windows 7. Even Mac used to do these, like actual DVDs or CDs. Now they're on USBs if you get them. That's what they are. They're brand new machines you install from. That's what that ISO file is. It's being installed onto a USB, a floppy disk, or maybe 12 floppy disks back then. Now it's you just take the file and you use that. You don't have to put it onto any extra special thing. Can you access the VM from the host OS? Depending. That's where the networks come in. You have to have it set up. You could put it in bridge mode. I would be aware of the consequences. You're putting a machine that you may or may not have secure on your actual operating system. That's the easiest way to make it talk to the host machine. There is possible port forwarding or SSH. That's the easiest way, especially in VirtualBox, but there are other ways. I'm trying to think of the easiest way to get you. Look it up, honestly. If you want to connect without using VirtualBox, without using bridge mode, there are ways. It's port forwarding, I believe, is how you'll find it most easiest. But look it up on Google. It should be pretty quick. If not, send an email to someone and they'll get it forwarded to me, and I can answer that question more easily. I don't know if I'm supposed to say that, but yeah, why not? Can a chat file be included? Trying to think. Excellent. How to set up RIMNUC, okay, in the lab for malware analysis. So you're going to want to have a Linux, I believe, machine already running and install that onto it, that program. And that's going to be the easiest way to understand PCAPs and debunking UEBA. So user and entity behavior analytics you're going to need a pre-built operating system, I believe, already set up. There might be an OVA file, so a pre-built virtual machine that already has all that set up. They just need to download it. It needs to say it's a VirtualBox OVA. If it is, download it, and you're going to click on Import OVA inside of VirtualBox and do that. If not, you're going to need to have probably Linux set up to be able to do that, and Wireshark to get PCAPs. Thank you for enjoying my live instruction. Thank you for the old references. Hey, I used to play Doom. I look a lot older than I look a lot younger than I actually am. I will say that. Can ISP track the IP of a VM if it's on the networking? I mean, they're going to be able to track depending. That's a good question. Directly, they're not going to be able to track the internal. So the question is, can an internal internet service provider, can an internet service provider
Did we lose you, Eric?
No, I'm back. All of a
Okay.
sudden, like Zoom just turned off for a second. I don't know. It's back. So here I am once again. Okay. So it says, the question was, can ISP track an IP? Yes and no. They're not going to really know what the internal IP address is using what's called NAT and a few other things. But they are going to know what your external IP address is because they're the one that give it to you. And if you're using them as a DNS server, they're going to get a list of all the domains you're going to. So essentially, they're not going to know your IP, but they're sure going to know what you're doing, unless you change some stuff. So I started working with, Windows 3.1. Hey, that's NT though. And you're still using NT to this day. Can you access files on the VM from the OS? So can you access files on the VM from the OS? You can do what's called set up a shared directory or copy and paste. You're going to install something called VirtualBox Guest Editions and basically be able to copy the files over. Install VirtualBox Guest Editions, look that up, and you'll be able to either set up a shared folder where it's a folder that both the virtual machine and your OS, your host OS, can both access to drop directories into, files and directories into, or set up drag and drop, where you can literally drag from your host OS to your VM, or from your VM to your host address, or you can set up bidirectional, so it can do both. And then all about me getting back. Excellent presentation and Q&A. How do you fix the error if the kernel driver is not installed? Really good question. It depends what OS you're on. If you're on a Windows, you're going to need to go into your BIOS and make sure you have virtualization enabled. If you're on a Mac, you go into settings, go into security and privacy, and it should say, hey, you have got Oracle VirtualBox is trying to access this, and you just have to allow it. If you are so concerned with privacy, use Tor and proxy. Yes, specifically a proxy, I would say a VPN and proxy especially, and a good VPN. Don't use a free VPN. Use a notable VPN like Proton VPN. I actually had no idea about the virtual machines. Not even talking about VirtualBox. Awesome, glad you liked it. And cool, there's a Discord. Yep, VT enable, that's what you need. Awesome, I think I've got all the questions.
There was one kind of back in the beginning of the Q&A box. How do you mitigate that single huge machine being a single point of failure?
Okay, so you mean is that a question, if they're still here, for server-based virtualization, how can we make that one machine not a single point of failure? If that is the question, I'm going to answer that. And there's a couple ways. Easiest one is backing up that machine, having a physical clone of that machine itself, which, yes, that's a big thing. So I would say you can either clone that entire machine or every VM on it clone those VMs and have them stored somewhere else. So if that machine goes down, you've got them stored on another machine, another big physical machine that you can spin them back up. Is it possible to connect with me on LinkedIn? It is. My name is Eric Keith, and I personally am never on it, but I do try. After presentations, I do try to get on it and look at it. The question is kind of like RAID systems. So RAID regarding, wow, I just totally blanked. Regarding networks and backing up and how striping. So sort of, you can do it that way. So in case a drive goes down, you can have another drive repair, spin up or copy stripe to another machine. That could be, or you just have it on, have it so each of those machines is quite literally backed up onto another machine somewhere else. So if that machine goes down, you get notified. I think there was an automation question or an automation comment. So as Simon said, that's what I would do. I would have RAID set up, specifically certain kinds of RAIDs. Not going to get into that. I'm not going to explain RAID because that will be outside the scope of this. But I would have it backed up to another machine and use a program that would notify me, hey, this machine went down, go turn this backup on. And it would have the same MAC address and everything else set up.
Awesome. I think we are right at time here. But kind of to close this out, Eric, for the folks who are still on the line, still have questions about cybersecurity, what is like one thing that you suggest that they do to continue learning cybersecurity?
So I have this in here actually. When I first got into cybersecurity, it came from IT, and I already knew about virtualization, but I only knew virtualization from being in industry. I didn't ever thought about doing it to learn anything. It was like, oh, I'm going to use virtualization because I've got servers to run. And then the guy's like, well, why don't you use virtualization to actually start learning how to do Linux better, actually learn how to automate, learn how to do all this. And so that was the first time I ever thought about actually using this technology for myself, if that made sense. And so I think that was a big thing for me. And then the next step was doing it, finding what I'm really passionate about, which in my area, I love systems. I came out of IT. I'm a sysadmin. Everyone who's had my class will know I related back to either Python or systems. And I used virtualization to start learning more about that. And it made me enjoyable because I hated network starting out. I will say that I hated networks. Gave me RAID. I'd be like, no, I'm never going to talk about RAID. But nowadays, learning from the stuff I wanted to enjoy, I realized, hey, I'm at a wall until I learn this next step. Even wasn't necessarily what I wanted to learn. It helped open up to more avenues. So I think you guys are doing great. Virtualization is the first step. It is, in my opinion, one of the very first steps you can take in cybersecurity. The next step is utilizing it, doing it. Actually, not just me showing you, but you actually going and doing it. And from there, I would start, what do you enjoy? Learn Linux, learn more operating systems, go learn about the networks. And from there, what are the technologies? Someone mentioned UBA and PCAPs. That's awesome. Go and learn about them. That's much more advanced using what Syed talked about, I think, last time. But just go down that rabbit hole. The rabbit hole, in my opinion, is the best way to learn. And if you've been ever in any of my classes, you'll know the rabbit holes are the way I teach. It's just pull that thread and keep going, because as long as we hit the topics, who cares how we got there? And so go down that rabbit hole and see what you enjoy and just keep going and learn from your mistakes. Does that answer your question, Jordan?
Yes, it does.
Awesome.
Well, thank you so much, Eric, for being here, sharing your knowledge with us. I will, as mentioned, send the recording, the slides, any relevant links in my recap email to you tomorrow. And then hopefully we will see some of you at the Intro to Cyber Certifications meetup tomorrow evening, which I will share the link to. So, all right, everybody, have a good rest of your day or evening, and we hope to see you again soon.
See y'all. Bye.
Bye.